Today's topic is design of experiments. Let's begin with a small introduction. In 1935, Sir Ronald A. Fisher laid the foundation for the subject, the design of experiments. Since then, the theory of experimental design has been considerably developed and extended. Applications of this theory are found today in laboratories and research in natural sciences, engineering, and nearly all branches of social science. Experimentation provides what is called experimental data. I repeat, experimentation provides what is called experimental data. In contrast to observational data with which we can be mainly concerned up to this point. I repeat, experimentation provides what is called experimental data in contrast to observational data with which we have been mainly concerned up to this point. Observational data. These are represented by observations on the elementary units of a population or of a sample and are not changed or modified by any attempt on the part of an investigator during the course of observation. It is often difficult to assign cause and effect by studying observation data. If one is interested in establishing causal relationships, he should work with experimental data. Data arising from observations on a universe or a segment thereof which have been controlled or modified by varying certain factors in order to determine what effect, if any, the factors have on the data. In other words, experimental data are the results from logically designed experiments which provide evidence for or against theories of cause and effect. The subject matter of design of experiments includes: number 1, planning of the experiment. Number 2, obtaining relevant information. From it regarding the statistical hypothesis under the study. And number 3, making a statistical analysis of the data. Experience has shown that proper consideration of the statistical analysis before the experiment is conducted forces the experimenter to plan more carefully the design of the experiment. So, accordingly, the design of experiment may be defined as the logical construction of the experiment in which the degree of uncertainty with which the inference is drawn may be well defined. The experimenter may easily recognize three important phases of every project. Number 1, experimental or planning phase. This has: number 1, statement of problem. Number 2. Choice of response or dependent variable. I repeat, choice of response or dependent variable. Number 3. Selection of factors to be varied. Number 4. Choice of level of these factors. Which has further quantitative or qualitative. And fixed or random. And number 5. How factor levels are to be combined. I repeat, how factor levels are to be combined. Number 2. Design phase. As further the following. Number 1. Number of observations to be taken. Number 2. Order of experimentation. Number 3. Method of randomization to be used. Number 4. Mathematical model to describe the experiment. Number 5. Hypothesis to be tested. And the third one is analysis phase. Which comprises of number 1. Data collection and processing. Number 2. Computation of test statistics. Number 3. Interpretation of results for the experimenter. I repeat, interpretation of results for the experimenter.